All right, so chapter 12 things. So it's not the most difficult chapter for sure that we've done. May or may not believe it's the easiest chapter we've done, but it's a chapter. So with systems of linear equations, that's what the first two sections are about. Uh, there are always three possible outcomes when you're dealing with three or two variable or three variable systems. Uh, there's one solution. That's the most common thing that happens. The mathy words for one solution are consistent and independent. So one solution is also called a consistent and independent system. Answers would be as ordered pairs, or if it's three variable system, ordered triples, X, Y, Z. Or if it's different letters in there, it's always in alphabetical order. That's why they do the triples there. Infinitely many solutions is another possibility. That means that it is consistent and dependent. So that there you're going to get to solve for an indicated variable. So they'll tell you to write your solutions in terms of X or in terms of Y or possibly in terms of Z, three variable system. Infinitely many solutions. If it's linear, it's like two lines that lay right on top of each other. So one solution with lines is lines that cross and they have one point that's in common. Infinitely many solutions is two lines that lay right on top of each other. With three variable systems, there's multiple ways that can happen. You could have two planes that lay right on top of each other, or you could have three planes that all intersect at the same line, which creates an infinitely many solutions. The third possibility is the no solution scenario, and that means that the lines never touch; they're parallel. That's what's happening. With three variable systems, they don't necessarily have to be parallel; they just don't all line up to be one solution or infinitely many. So it could be a scenario where you have two planes that cross this over here, and then a third plane that's like way over here that doesn't even touch those, in the same places. So no solution is also called inconsistent. So consistent means you got answers. Independent is one answer. Dependent, infinitely many solutions. And then no solution is called inconsistent out of that. So typically we use the first words there, no solution, infinitely many solutions, and one solution. But you do need to know those other words for that. So when we're solving systems of equations, you've done this before. There are different methods for doing that. So we're just going to review those methods. Substitution is a method for solving systems. So let's do this first one by substitution. So substitution, good method. It's Coach Mack tends to do a lot of them through substitution. That's his favorite way. It's not my favorite way, but it's a way. So with substitution, the key thing that you want to do is get one of the equations to have a variable by itself. Doesn't matter which one, you pick the one that's easiest. So on this one, the first equation would be the easiest to get y by itself because it's just one move, right? So that's why I would just take and subtract 2x from both sides and get y equals negative 2x plus 5. And then I'm going to take that stuff and I'm going to substitute it in to y in the second equation. So I've got negative 4x plus 6, and then instead of y, I'm going to put in that negative 2x plus 5 that I'm substituting for that y. And now I've got this equation that only has x's in it. So that allows me to solve it for x. So I'm just going to distribute. So I've got negative 4x minus 12x plus 30 is equal to negative 2. I'm going to put those x's together. So that's going to be negative 16x plus 30 equals negative 2. And then subtract 30. Negative 16x equals negative 32. That's going to work out nice because then it ends up being positive 2 is what x is. So if x is positive 2, I can take that answer and then substitute it into my equation that had y being negative 2 x plus 5. So I'm just taking that answer I found and plugging it back into one of my other equations. I went back to the one that had y equals. You can go to any of them to do that. That's absolutely legal to do. So I'm going to use the easy one, though. That's going to be negative 4 plus 5, which is going to be y equals 1. So we get the solution as an ordered pair, 2, 1. So we get the x value, the y value, and then an ordered pair out of that. So substitution, absolutely a fine way of solving systems algebraically. Works out great. Good skill to have. My favorite way, we're going to do the same system, but we're going to do it with elimination, which is my favorite way to solve systems. I just really like elimination. With elimination, what you're trying to do is get opposites on one of the letters so that you can cancel it out by adding the two equations together. So when I look at that, I see a 2x and a negative 4x. I could change that 2x to a 4x by multiplying by what? 2. So I'm going to multiply this entire first equation by 2. So I got to multiply that whole equation by that. And that's going to give me 4x plus 2y equals 10. And then I have negative 4x plus 6y still equal to negative 2. So I didn't do anything to the second problem. With elimination, you can, if you need to multiply both of them by something, you can. If you just need to multiply one of them by something, you can. That's absolutely legal to do. Here, I just needed to multiply one. And then what's going to happen is the x's are going to eliminate one another. And then when you add the y's together, that's going to be 8y. And then 10 and negative 2 is positive 8. This is why I like elimination, because I get a one-stepper to finish it with here. All I got to do is divide by 8. And y is equal to 1. And then I'm going to take that answer and plug it back into one of those equations. It doesn't matter which one you go into. I usually try to avoid the one that has the most negative signs in it, just because you got a chance of making a sign mistake if you do that. So I'm going to go back to that top one, and I'm going to plug in 2x plus 1 equals 5. So I'm replacing the y with 1 in that top equation. And I'm just solving it for x now. Minus 1, that's 2x is equal to 4. Divide by 2. And x is equal to 2. That's the same answer that I found on that by doing it by substitution. Ordered pair 2, 1. So substitution, great way. Elimination, great way. Both of them get you the same solution. So it doesn't matter. And on the test and stuff for this, all I'm going to say is solve. You pick which method you like. If you're really good at substitution, do that one. If you're really good at elimination, do that one. Or you can do it by graphing even. So let's solve this one by graphing. Graphing is probably my least favorite way of doing it because it doesn't always land at a nice spot. This system does land at a nice spot, but not every system does. But graphing is a valid way of solving it. So if you're going to graph, you're going to get y by itself for both equations. So in this case, we got y equals negative 2x plus 5. That's the first one. And then the second one, I got to do a little bit more work here. I got 6y is equal to 4x minus 2. And I'm going to have y is equal to 2/3 x minus 1/3. So got some fractions to deal with there. So I'm going to graph those two. And I'm going to use my calculator to do it. I'm not going to draw it by hand because that would be barbaric. And we live in a nice little part of the world here. So go to the calculator. Make sure if you got a scatter plot turned on from that you turn that scatter plot off. So you can go to second y equals and make sure all your plots are off out of that, because if you don't have that plot off, it's going to give you an error on your graphing most likely. So I'm going to graph those two equations. So I got negative 2x plus 5. And then I have 2/3 x minus 1/3. So fraction button, 2/3. So that, get out of there. X minus fraction button, 1/3. And then I'm just going to hit graph. And if your window isn't a 10 by 10, remember Zoom 6 will reset your window. And then we want to find where they're crossing. So we did this a lot in topic 6 or in chapter 6 when we were doing those equations where all we had to do is hit second trace, and we're finding the intersection of those two. So option 5, and then just hit enter 3 times. And it'll find that intersection at 2, 1. So very much, a good way of solving. If it's not a nice lattice point, not right on a corner there, it makes it a little bit more difficult to solve, but still not terrible as far as solving ability there. It is, since you have the calculator, it can give you decimal approximations for the crossing spot really nicely there, okay? And then what typically tends to be the favorite method of most students is the last one we'll talk about here, which is Gauss-Jordan elimination or using a matrix to solve. So what we're going to do is we're going to take that system and we're going to create a augmented matrix. So taking that system and we're putting it into a matrix. That matrix is going to be a 2 by 3 sized matrix. 2 rows, 3 columns. The first row are the numbers from the first equation. So 2, 1, and 5. The second row is going to be the numbers from the second equation, -4, 6, and -2. So if you're going to use a matrix to solve it, you got to make sure it's all in standard form, like x, y, and then what it's equal to. Make sure they're in that order. This is typically how most students end up solving that. I go over the others because when we do nonlinear systems in the last section, you need those other two methods because the matrix doesn't work for them. All right, so here we have that, and then we're going to run on our calculator. We're going to put that matrix in, and we're going to do RREF. Okay, and that's going to give us a solution matrix. So I'm going to go to the calculator. I'm going to hit second, and then right there beside sign is the matrix button. It should take you here. And we want to go over to edit. And I'm just going to edit matrix A. My matrix A right now is a 3 by 3, but that's okay. I'm going to change it when I get in there. I'm going to change it to a 2 by 3. And I'm going to put that matrix into my calculator. So I have a 2, enter, 1, enter, 5, enter. Then the second row, I've got -4, 6, and 2. Is it -2? Yeah, okay. Thank you. Let me go back and fix that. Yeah, make sure you get those numbers right, because if they are not, it will mess you up. Kind of like dialing the wrong. Y'all don't dial anybody's number anymore, but if you don't have the right number, it's not going to get you the right person. So we got those in there. Second quit to go back to the regular calculator screen. Then second matrix and go back to math, and it's down toward the bottom is where RREF is located. If you don't remember, you did this in Algebra 2. And then it asks, okay, you want to do reduced row echelon form for what? And so it gives you the option of what you want to do that with. I want to go back to matrix, and I put mine in matrix A. So I'm under names, I'm going to select matrix A and hit enter. And here we get the solution matrix, which is the identity matrix 1, 0, 0, 1, and then up here is 2 and 1. So the top row gives you X, 1, 0, 2, 0, 1, 1. That tells us that X equals 2 and Y equals 1. ordered pair 2, 1. So no matter which method you solve by, we always end up with the same solution, 2, 1 out of that. Okay. So we've solved that same system several different ways. I don't care which way you do it. When it says solve the system, solve it. Whichever way you feel like is the best for you, and it may matrix may be the way you want to do every one of them. I'm okay with that. I don't care. Okay. So it just says solve out of that. So let's take a different system and solve it. Okay, so here's this system, a little similar, but a few major differences. So we have 2x plus y is equal to 5 again, and then we have a 4x minus 8 is equal to negative 2y. So what method would you like to solve this one with? Matrix sounds good to me. To solve it by matrix, though, I need to fix this second equation. It's not in the right order. So I need to move this 8 over here and move this 2y back over to the left so that I've got 4x plus 2y equals positive 8. And then so my matrix that I'm going to put into the calculator is 2, 1, 5, 4, 2, 8. And I'm going to run RREF on that and see what it gets me. Second matrix, go over to edit. I'm just going to do matrix A again, 2 by 3. And I've already got that first row the right way. I'm just going to change my second row. 4, 2, 8. Second quit. And then I'm going to tell it to do the RREF of matrix A. All right, so this one is a little weird. It doesn't look exactly like the other one. It gets us a 1, 0.5, and 0, and then 0, 0, 1. That bottom row is the interesting one. Because this row really says 0 x's and 0 y's is equal to 1. Is there any way you could add 0 x's and 0 y's and get something other than 0? That can't happen. 0 times x is 0. 0 times y is 0. So if I'm adding 0 and 0, I can't get 1 back from that. So this bottom row tells me, because it's like that this is a no solution problem. This is a no solution system because of that bottom row. It has zeros on the left and then a 1 or any other number on the right. Okay, anytime it's got something else on the right there, that's when it's a no solution out of that. So that's an interesting system. If you had solved this by substitution or elimination, what you would have found is that the variables would cancel out completely in the problem, and you get something left that's false. It'd be like 0 equals something, like 8 or something like that. So if you did substitution or elimination, you still end up with no solution. It just, all the variables are going to cancel out. Okay, and you get something left that's false. Let's try to solve this one. So a couple of changes on this one, so a little bit different system. We want to solve that one. And you choose what method you want to use. It doesn't matter. I'm going to use matrix method. And because it's already in the right form for that. So I don't even have to, or it's almost in the right form. I'm going to put the -6 first. That'll put it in the right order. So they about caught me sleeping there. So that's a -6, -3, -12. And I'm going to run RREF on that. Second matrix, go over to edit. I'm going to use matrix A again. This one we have 2, 1, 4. And then we have, skipped over here, -6, -3, -12. sure I got all my numbers right. Yeah. Second quit. And I can either go back up here and copy paste RREF of A, or I can go through the menu and find it again. I'm just going to copy paste. Now, this one looks it's similar to the previous one, but a little bit different. That bottom row has all zeros on it. So we have, yeah, that means it's an infinitely many solutions there. So we have, that's a 2 over there. So 0, 0, 0. That bottom row tells me that this is infinitely many solutions. Anytime we got a bottom row that's all zeros, because 0 plus 0 does equal 0, so that always works. So this tells me that this is infinitely many solutions. And we want to, so since it's infinitely many solutions, let's write the solutions as a U in it, not a Y, in terms of X. Okay, so they're going to tell you what letter to write the solutions in terms of. So if you're saying and write it in terms of X, what you've got to do is take that top row and pull it out of the matrix as an equation. So that top row is X plus 1/2 Y equals 2. Right? Now, if I'm going to write that in terms of X, that means X is the variable that's going to be in there. So I want to solve this for Y. So I'm going to subtract X. And then I'm going to multiply by 2 to get rid of that 1/2. So it's going to be Y equals negative 2X plus 4. So writing the solutions in terms of X, the ordered pair is going to have X in the X position and then negative 2X plus 4 in the Y position. So this is a little step further than what we probably did in Algebra 2 with the systems of equations. In Algebra 2, we just would stop and say it's infinitely many solutions. This is a step further for us to do there. So they will tell you what letter to write your solutions in with that. So doesn't really, you know, and if they said in terms of Y, that means get X by itself. That's what it means. All right, so two variable system, you got all of those methods to solve with. Most of us end up picking matrix method just because it just spits out the answer to us. We don't have to do a whole lot of work there. Now, the next thing is three variable systems. So three variable systems can be solved by hand, but nobody wants to do that stuff, okay? Because it's a substitution elimination a couple of times to get it down to a two variable system, and then it's substitution elimination to get that solve that two variable system, and then you got to go back and plug in a bunch reverse solving there to get your solutions. So typically, if it's a 3x4 system, which is what this is, 3x4, you're going to put that into a matrix. So put that into a matrix and run RREF on that. We're going to second matrix, go over to edit. I'm just going to use matrix A again because I'm boring like that, and change it to a 3x4. Okay. And then we're splitting that in 1, 1, negative 1, negative 1. 4, negative 3, 2, 16, 2, negative 2, negative 3, 5. And then I'm going to tell it to run RREF on that matrix. Whether you copy and paste that or go through the menu, it's either way. And we get this matrix left over. We get 1, 0, 0, 2, 0, 1, 0, negative 2, 0, 0, 1, 1. So that top row tells me that X equals 2. The second row says Y equals negative 2. And the bottom row says Z equals 1. this is a one solution system. The answer is an ordered triple, 2, -2, 1. So, solving that system using the reduced row echelon form with the calculator. That's kind of nice. All right. Let's see about H. Let's run that with the matrix. 3x4 matrix, run that and see what we get. Edit 3x4, 2, 1, -1, -2, 1, 2. Run RREF on that matrix. Now, when it spits you back these decimals out of that, it may be hard to see the whole matrix. What you can do is hit Math, Enter, Enter, and it'll convert those into fractions for you, so that it doesn't take up as much space. Because sometimes if it's really long decimals there that don't, it'll or more than one of them is a decimal, it may be where you have to like scroll to the side to see everything. So if you hit Math, Enter, Enter, it'll change them to fractions for you. But what do we see here on that bottom row? Yeah, this would be a no solution situation. Because of that bottom row, that tells me that it's no solution. Not much to do there. Just say no solution, or inconsistent is another word for no solution. See if you can do I there. Solve that system. I would use the matrix to do that. All right, so this one, we end up with that. That bottom row has all zeros on it. So that tells me that this is infinitely many solutions. I want that in terms of z. Okay. Infinitely many solutions in terms of z. So I'm going to take those two equations that I have in the matrix there. I've got x plus 5z equals 22. And then the second equation, I've got y plus 3z equals 7. If I want that in terms of z, that means I want z in my answers. So for the x plus 5z, I'm just going to move the 5z over. And there's x, negative 5z plus 22. For the y, I want the answers to have z's in it, so I'm going to get y by itself. So subtract 3z. Y is equal to negative 3z plus 7. The ordered triple then looks like this. Negative 5z plus 22, negative 3z plus 7, and then the z spot's just a z. What is happening here is you've got three flat planes that are meeting up on a line. And if you plug in any z value, you can get the y and the x value that go with it, with that. So three planes that all intersect in a line. That's what you have with this situation. That's what's going on with these equations. Solving by graphing is definitely probably not an option on this because it is very difficult to do the graph in 3D. But we've seen one solution. That's the most common thing. That's going to happen most. No solution, all zeros and equal to a 1 on the right. And then all zeros across the whole bottom row is our infinitely many solutions. So be able to recognize those and then get our infinitely manys in that form with whatever letter they say. Usually if it's 3 variables, they'll say z. If it's 2 variables, they'll usually say x. Now, last thing in this section is row operations. So this is a non-calculator activity because it's easier to do without. So when you're doing row operations, they're going to tell you what row operations to do. They're going to give you a matrix. I got a matrix right here. And then they have you a row operation or row operations to do. So we have 2 times row 2 plus row 1 equals row 1. What this says is row 1 is the only change. Okay? So when I go, after I do this matrix, this row operation, my row 2 is still going to be 0, 1, 3. Row 2 doesn't change. Row 1 is the one that changes because that's what it said it equals. Okay? We're going to use row 2 to make that happen, but we're not going to change row 2. So we're taking 2 times every value in row 2. So 2 times 0 is how much? And we're going to add it to the corresponding spot in row 1. So 2 times 0 is 0, plus 1 is 1. So that first spot is going to be a 1. 2 times 1 is 2, plus negative 2 is 0. 2 times 3 is 6. Plus 2 is 8. And we've done that row operation. That's all we're doing there. Okay. Now, that's what your calculator is doing in the background when you do that RREF. It's running these row operations to get it down to the solution of that. Okay. The answer is that whole matrix. This is not from a system, even though we kind of feel like it is. It's just a matrix they're going to give you and say do these row operations. So here's one where they give us 2 row operations to do. Okay. So you do, when they give you multiple row operations, do it in the order that they give them to you. So the first one, we're taking negative 3 times row 2 plus row 1. What row is changing? Row 1, row 2. No. Just row 1 for the first one. The second one, yeah, row 2 is going to change. But the first one, we're doing it one piece at a time, like Johnny Cash said. We build it one piece at a time. So on the first one, I'm going to copy down row 2 and row 3. I'm not changing those. Don't try to do too much at once with this because it just gets confusing if you do. So we're taking negative 3 times row 2 and adding it to row 1. So negative 3 times 5, negative 15 plus 2 would be negative 13. So row 1 has a negative 13 right there. And then we're taking negative 3 times 3, which would be negative 9, plus negative 4 is another negative 13. Then negative 3 times negative 7 is positive 21, plus 9 is 30. So row 1 is the only one that changed on step 1, or row operation 1. Row operation 2, Row 2 changes. So my row 1 is now the negative 13, negative 1330. My row 3 is 1, 6, negative 10. It still hadn't changed. Row 2 is the one that changes. So I'm taking 5 times row 3. 5 times 1 is 5, plus row 2 would be 6, or 5 plus 5 is 10, sorry. So that's 10. 30 plus 3 would be 33. Negative 50 plus negative 7 would be negative 57. There is the final answer after both of those row operations have been done. So all you got to do is follow the directions for row operations. They're going to tell you what to do. I'm not asking you to make up your own row operations. They're going to give them to you. You just follow the directions. That's a pretty easy thing. All right, so I've got the practice problems there. One of the packets you picked up was the review. I would probably stick to just being able to work through the review for that. Let's go ahead and move over to 12.2 and 12.3 and do it. It's pretty short as well. So just trying to cover all of the things that you're going to have and still give us a day to study for the final. Okay. All right. So 12.2 and 12.3 is matrix operation stuff. So we're going to do determinants of a matrix in this section, and determinants of a matrix are just like a property of that matrix. It's a number that you get back. It only is possible to find a determinant of a square matrix. Square matrices are like 2 by 2s, 3 by 3s, or n by n. So you could have 4 by 4, 5 by 5, 100 by 100, all that fun stuff. But 2 by 2s and 3 by 3s are about the most common ones that we'll do out of that. So 2 by 2s are really easy to do without a calculator. They're actually faster to me because it takes me too long to type them in. So a 2 by 2, you can do the determinant, and so there's two different notations for determinant. One of them is the abbreviation DET, and then they'll put the matrix beside it in parentheses. Or this is also means determinant. It looks like absolute value signs around the matrix. Okay, that also means find the determinant. The way you find the determinant of a 2 by 2 is you just multiply the diagonals and then subtract them. So left diagonal starts in the top left times bottom right, A times D, and then top right times bottom left, B times C, and then you subtract those answers. That finds you the determinant of a 2 by 2. So like for example A, it's going to be 2 times 5 minus negative 1 times 3. And you're just working that out. So that's 10 minus negative 3, which ends up being 13. Your calculator can also do a determinant. I want to show you that as well. So in case you want to do it with the calculator, it's fine. So on the calculator, I'm going to go to the matrix menu. I'm going to go over to edit, pick whatever matrix you want to pick. I'm going to pick a matrix A, and I'm going to change it to a 2 by 2. And I'm going to put those numbers in: 2, negative 1, 3, 5. Second mode to get back to the regular calculator screen, and I'm going to tell it, go to matrix, go over to math. That very first option is DET. That's the determinant. So I'm going to hit enter, and then it says, okay, find the determinant, which matrix you want to do. So second matrix, I put mine in A, and then just hit enter, and it finds that determinant. I'm faster with 2 by 2s, but just doing it by hand. But you're welcome to do it with the calculator if you want to. Anything bigger than a 2 by 2, I usually do with the calculator. I could teach you how to do it by hand, but I don't think it's going to benefit you in college algebra to do that. If you need to do one by hand later on in life, you will have a professor that will teach you that because you're in probably a linear algebra class because you're going into engineering or something. Okay, so on this 3 by 3 here, let's put that in the calculator and let it give us the determinant of that. So go to the calculator, go to the matrix, Go over to edit. I'm going to do matrix B this time just for the heck of it. 3 by 3, and then 2, -1, 3, -2, 5, 1, 0, 6, -9. All right, and then I'm going to tell it, go to matrix, go to math, determinant of matrix B. That's where I put mine. Get a -120. Nothing just fancy about that. It's a number. Right? As long as that number is not 0, the matrix is what's called invertible. Not that is super important for you guys in college algebra, but it is a thing. So invertible matrix has a determinant that is not 0. All right, here's an application of a determinant. So how can you use this for anything? If you had a triangle that was plotted on a coordinate system, you can find the area of that triangle by using the determinant to get the base times height. So the formula is remember formula for an area of a triangle is 1/2 base times height. The 1/2 is here, and then this or this, both of them work. Doesn't matter where you put if you do a row of ones or a column of ones, it doesn't matter. I usually do the columns just because it's X, Y, 1, X, Y, 1, X, Y, 1. That to me is easier to put in. So this determinant is the base times the height, is what it ends up being. It's the number that the base times the height is. What good is that? Well, if you are looking at a map, you can get coordinates for points on a map, and you could find the area, triangular area of a space on a map using that. That's what it really could be used for. So pretty neat thing there. So let's do this one. So we got the ordered pairs are 3, 4, -5, 6, and -3, 1. It doesn't matter which one of those you call X1, Y1, X2, Y2, X3, Y3. Doesn't matter. Okay. So I'm going to put that into my calculator. Second matrix. Go to edit. I'm going to use matrix B because it's already 3 by 3. And I've got 3, 4, 1. -5, 6, 1. -3, 1, 1. Second quit. Get the determinant of that. It's 36. So we have the area is 1/2 times 36, which is 18 square units. Using just an application of determinants. We don't have many of them, but this is one of them that we talk about. There's a few other things that are a higher level. There's a lot more to it with those, but this is a pretty easy way to use the determinant. Okay, so determinants of matrices. All right, next thing is scalar multiplication. Scalar multiplication is like distributed property. So 8a just means multiply everybody inside by 8. So that's 24, 48, 32, 64, -40, 56. And you've done the scalar multiplication. As boring as it gets. You can do that with the calculator as well. If you put this matrix in 2 by 3 and then type into the calculator 8 times matrix A, it will give you this matrix back. Okay. All right. Adding and subtracting matrices. In order to add and subtract matrices, they got to be the same size. Must be exactly the same size. So A and B are the same size, so I can add those or subtract those. But C is a different size. It's a 2 by 3, so I cannot subtract A and C. it's an undefined operation because they're not the same size. So adding and subtracting, they got to be the same size. The reason is to add and subtract matrices, you just add the matching spots. So A plus B, I'm going to add 2 plus negative 5, get negative 3. For the next spot, 6 plus negative 8, get negative 2. For the next row, I got negative 5 plus 13, which would be 8. The next spot, 8 plus 6 is 14. Third row, 10 plus negative 14 is negative 4. Negative 11 plus 4 is negative 7. And I've added those two matrices together. If you don't trust yourself, you can put matrix A into your calculator and put matrix B into your calculator, and then go to names, select matrix A, hit the plus sign, select matrix B, and it will add them up and give you this back. I generally don't do addition or subtraction in the calculator if it's just straight up add or subtract. Now, problem like G adds a little bit more work to that. So I'm going to go ahead and put matrix A and matrix B in my calculator because it's got to do a scalar multiplication as well. So I'm going to go to the matrix. I'm going to go to edit. Matrix A, this was a 3 by 2. So it's 2, 6, negative 5, 8, 10, negative 11. Go back to the matrix, go to edit, and then matrix B, change it to a 3 by 2 and put that matrix in there. It's negative 5, negative 8, 13, 6, negative 14, 4. Now, this is where I'm going to do that. I'm going to type in exactly how it's written on my notes there, that I'm going to do negative 3A minus 2B. So I'm going to go to my calculator. I'm going to type a negative 3, then second matrix A minus 2 second matrix B. And it cranks that out for us. We get this matrix here. It's left over. If you wanted to do that by hand, you absolutely could. You just got to do the steps. Order of operations still runs everything. So multiplication would happen first. So you'd have to scalar multiply by negative 3 and by 2, and then do the subtraction. But the calculator works pretty nice for that too. All right. Multiplying matrices, I definitely do that with the calculator. It can be done by hand. And in algebra algebra 2, they actually want you to be able to do some of it by hand. The good thing about college algebra is I don't care if you do it by hand. Just do it with the calculator. Okay. So when you're doing multiplying matrices, the columns left matrix. So when you look at the dimensions of the matrix, it's row by column. So the columns of the left matrix have got to be the same size as the rows of the right matrix for you to be able to multiply them together. If those two numbers in the middle don't match on the dimensions, you can't do it. It's an undefined operation. Okay? What happens is those two numbers match, and the solution is going to be the size row left by column right. So a 2 by 3 times a 3 by 5 gets you a 2 by 5 when you get done. Okay? So good news about doing it with the calculator is it'll give you an error if it can't be done. It'll just tell you dimension mismatch, can't do it. Okay. So let's look at this problem. So here we have a 3 by 2, and here we have a 2 by 1. Can that be done? Yes, those numbers in the middle match. So I know I can put that in. So I'm going to go to my calculator, and I'm going to put in that matrix. Second matrix, go to edit. I'm going to put it into matrix A. It's a 3 by 2. So 2, negative 3, 5, negative 7, negative 8, 12. Second quit, go back to the matrix, go to matrix edit, matrix B. This one is a 2 by 1. It's got a 10 and an 11 in it. Then I'm just going to tell my calculator matrix A times matrix B. I don't think you even have to put the multiplication symbol in there, but I always do out of habit. And there we get a 3 by 1 left over. Negative 13, negative 27, negative 52. And then 52. So matrix multiplication, put that in the calculator. Inverse of a matrix. So inverting a matrix, it's got to be a square matrix for you to find the inverse of it. This is another calculator thing. Okay. To find the inverse, you're going to put that matrix into your calculator. So I'm going to go to matrix A and edit that. Why I keep hitting y equals instead of second. Edit matrix A. This is a 2 by 2. 3, negative 5, 6, 4. Now I'm going to tell it to invert matrix A. So I need to tell it matrix A. The inverse button is the button right there beside sign. The x inverse. X of the negative 1 exponent, that's inverse. Enter. I'm going to hit math, enter to change it to fractions. So I got 2 over 21, 5 over 42, negative 1/7, and 1/14. That is the inverse of that matrix. See it. Now, we can use an inverse matrix to solve a system, but I actually usually don't do that. I'll usually just use the RREF version, to solve a system. Okay, so on the inverses, remember what I said earlier about the determinant. If the determinant is 0, you can't find the inverse. So on like this problem, the determinant of this, the DET of B, negative 6 times negative 2 is 12 minus 12, which is 0. So B inverse does not exist because it's a non-invertible matrix because the determinant is 0. If you tried to do that in your calculator, it's going to tell you that it's what it calls as a non-singular matrix, which means it can't be done. It's going to give you an error out of that. So inverting a matrix that has a determinant of 0 is not possible. Okay. The last page of this section there is solving systems. I would just put that in as a system and make it a 2 by 3 matrix, 3, negative 5, 18, 6, 4, 10, and do RREF instead of doing all this. Okay. So solving it by RREF is the way we already know how. So why do we need to worry about another method? Don't worry about another method. Okay. All right. Let's stop there for today.